So,
Oh, trapezoidal, yeah, we did.
so definite integrals, we've done approximations of definite integrals so far. The Riemann sums that we did with the rectangles, like we did the left rectangle, the right, and we did the midpoint, those were Riemann sums. Those were the approximate area under the graph, right? Remember that? Wasn't that was last week? What? Yeah. Okay. So all of these are examples of the Riemann sums. And then additionally, we did the trapezoidal rule. Okay. So what we want to do in this lesson is figure out not just an approximation, but the exact area under the curve. So the existence of definite integrals is just in order to find a definite integral. Means, number one, you want to look at continuous functions, okay? And you have to have a closed interval. Okay? So that's kind of what we want here. There's going to be a lot of notation, and I'm kind of just skim over it so that we can go more to the examples. Here. So just real quickly, guys, let's say we have a curve. Right, here's f of x. So in order to find, so let's say I want to look from A to B. If I don't put a bound, right, if it's not a closed interval, I can't find the area under the curve. What would happen if I didn't put bounds on A and B? It'd be infinite. So that's why we say this is the definite interval. So we need to find the exact. So this is the exact area under the curve. So that's what this means. Okay.
Leave.
Oh my God, David.
Don't disturb the class.
There's what's on the proof. Seriously. Okay. There's a bunch of notation. There it is. I can explain it. Okay, so I'll explain a couple things. Basically what we're saying, remember when we did the Riemann sums and we did all the rectangles? Imagine if we had infinitely many of them. Right? Limit as n goes to infinity. So if we had infinitely many of those rectangles, you would end up with the exact area. So that's what we're basically saying, that it's a limit.
So if those rectangles go on,
Right. So if you have
we get the exact
if you
area?
have infinitely many rectangles over the interval, so as the number of rectangles approaches infinity, you have your integral.
Only if it's m-gram though, right?
Well, it's kind of irrelevant because if you have infinitely many of them, the rectangles are going to form the exact shape of the curve. That's all. Basically what ends up happening is the rectangles have no width to them because they get, the more there are, the skinnier they get, the more narrow. So it's kind of irrelevant whether it's RRAM or MRAM.
It's one
Or,
idea.
yeah, I mean, you could say MRAM. It doesn't, for these purposes, since it's approaching infinity, it doesn't really make a difference. Okay, so here is our integral notation. We saw a little bit when we did trapezoidal rule, but I want to look at specifically what all of the pieces mean. So first of all, you'll see this upper limit, or sorry, the integral sign. It's an elongated S. So this means take all the sums as kind of representing the sum of all the rectangles. Now, we have two bounds. We have a lower limit of integration, that's A. So our lower bound and then our upper bound. So you might hear me say bound instead, because that's where the curve starts and stops. So A is like our starting point, B is our ending point. The integrand is whatever function we have here. So when I say my integrand, that's what I'm integrating. Got it. And then whenever you have this, you have to have dx. So for example, if I have a function like y squared, then I would need dy. If I would have something with, let's say 3w, then I would need a dw. So we just need to add on the end d, and then whatever variable we're integrating with respect to, that's all.
The x in the middle, is that going to be the number though? That's the
Yeah,
variable?
whatever
So
the-
it's gonna, so it would be f of w dw.
Right.
Yeah.
Makes sense?
Yeah, no,
So
I
far?
don't know what to do yet.
Well, we haven't done any examples. That's why I said I want to get to at least an example so that, what time are you guys leaving? Sam?
7 minutes.
Okay. All right, area under the curve. Well, we've already talked about this. Whenever you're looking at the integral, you're talking about the area under the curve. So the area between the curve and the x-axis is what we're looking at. So here's an example. The area under the curve for f of x equals square root of x. So let's just look. Here's square root of x from 0 to 4.
Yeah.
So I'm basically referring to this region. So that's represented by that integral. Yeah.
So is there a
Okay.
way to do it besides the calculator?
Yeah, there's a lot of ways. We'll learn all the formulas later. In this whole section, we're just going to be using area.
'Cause you
I'm
need
going
to
to
find
skip
the
this for a
slope
minute,
of the
and
line.
let me skip the calculator part and go right to this, because I want to just get a couple examples in before they leave. Let me explain. This right here, this means we want to find the area from -2 to 2 under the curve y equals square root of 4 minus x squared.
Is this inclusive, like, or would it be brackets or parentheses?
It's always brackets.
Always
So
brackets?
the interval is closed. That was one of the conditions that we had on finding the integral. It needs to be with brackets. So the first thing I want to do is graph that. Does anyone remember what the square root of 4 minus x squared looks like? It's a semicircle.
Not downward, but like.
You can put it on your calculator, but I'll just show you. It is, it looks like a semicircle from negative to, that's kind of
Your
one-sided, but.
semicircles are lacking. I mean, your straight lines are pretty good. Like,
Really?
did you miss that lesson at college?
Ha 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 ha.
You very.
Does it matter where it goes? Oh, yeah.
It's hard to do
Should go
when you're
through.
looking here.
Oh, she redid it.
It's still pretty bad, but okay, you get the idea. Now, I could approximate this by using rectangles, but we don't want that. We want to find the actual area. Well, so the whole goal of this lesson is to recognize what shape we have. I'm only going to give you shapes that you know. I'm going to give you triangles, rectangles, trapezoids, or maybe some part of a circle.
Did you find the right answers? I mean,
Did I find?
or did you just put it like the, you need the semi-circle?
I just made it.
Does it matter if it goes through two?
It just, does it matter? It doesn't, I mean, there's a point here and there's a point
Yeah,
here.
horizontally it doesn't matter. I mean, vertically it doesn't matter where it is.
Okay. So, how do you find the area of half a circle? 1 half pi r squared. What's the radius?
4
Try again.
2.
The radius is 2.
Oh, 2, yeah,
Oh,
sorry.
radius.
Diameter is 4.
Don't we have to do with the DX?
Nope. Oh, I forgot my dx, I'm sorry.
So isn't it just?
There should be a
pi?
dx after that.
So it's 2 pi?
It's just 2 pi.
You don't want us to actually have like the actual number? No? You want it in pi form?
I want it,
Alright.
yeah, just leave the pi.
And then do we keep the DX or do we just?
Wait, I'm confused.
I know, where did
So-
you, yeah, where did you go?
What'd you do?
Okay, so I
What-
forgot,
like, I'm
there's
just
actually,
saying Chinese.
Oh,
That's
God.
the answer.
Oh, God.
sorry, the dx is actually missing. I should have a dx. So what it's saying is take the antiderivative, in other words, I said above here, that the integral is represented by the area under the curve.
So wait, is 2 pi our answer? Is that the final answer?
That's the final
Yeah.
answer. You're done.
Sam, do you get it?
Where does the
Yep.
DX
I was
go?
interested in what it would be, and now I don't like it.
Can we do the second example very quickly?
Yeah. Okay, so real fast and then I'll slow down and I'll go back. One of the things that happens when we have integrals is sometimes the graph goes below the x-axis. When this occurs, anytime that you have part of the graph goes below the x-axis, it ends up being negative, okay? So let
If
me,
it, at any point of the graph it goes below.
yeah, so take a look at this graph. Okay, I want to find the integral from -3 to 3. So you see how this area is above the x-axis, right? This triangle here is above. So this is going to be a positive value. Okay? However, this triangle is below the x-axis. So this area here, this is going to be
Shouldn't it
negative.
Below the curve though?
Okay, so when I go to do the integral from -3 to 3 of this function, we don't know what it is. We can just see that here's the curve. Okay. So our first triangle, we'll just find the area of that. What's the area of this? It has a base of 3. So 3, the height is 2 divided by 2.
So that whole thing is just telling you to find the area?
Yes.
So equals
That whole
3.
thing's just telling us to find the area.
Okay.
And then we
This
do
one.
subtract.
Subtract, because the next part goes below the x-axis, and that's actually what I have right here. Area above the x-axis minus area below the x-axis.
Okay.
So I'm gonna
So
subtract,
0.
this has a base of 3 and the height of 2 divided by 2. So notice, this whole thing ended up being 0 because I had the same amount, it balanced out.
Wait, but where does the dx go into?
Okay, so the dx is just notation. The dx is just basically telling us to integrate what f of x is.
So that entire thing equals area.
Right.
So what happens when there's a curve?
So that's what we're going to learn in our next lesson. There are specific formulas that we follow. But for right now, we're only doing area formulas. So basically when you see the integral, just think, okay, that's area under the curve. Whenever I see this symbol, think area. A little delay. Okay, good luck, guys. There we go. Area.
Kicks the block.
Is it always area or there exceptions?
No, it's always area.
And will it always be area?
Always area.
Is it always under curve? No, that's negative.
Okay, so it's under the curve, which
Oh,
means
oh.
when I say under the curve, it's under the curve but above the x-axis. So it's kind of like, you know, just a quick example, like
The green.
like let's say if I had this, you know, something almost like the sine curve where it would go back and forth. So this would count as like a positive area, and then this would be a negative, and then this would be a positive. So you would just, if you wanted to find the integral from here to here, you would just figure out what those would be equal to, and then combine them. So anyway, anywhere it dips below the x-axis, we just count that as a negative.
Oh, never mind.
Okay, so I'm gonna just, all right, now let's show, I wanna go back to the calculator part, since we kind of skipped over that. Okay, so there are 3 ways to do this on your calculator, and I actually just typed this up, so I know it looks confusing. I hope it makes sense. So I want to look at this specific example. Oops. So the first one we're going to do is we're going to go to Y1 and graph it. Okay.
My question is, does anyone understand calculating the It's like,
What's-
It's messed up, because every time I try to graph anything, it
Yeah.
just says error.
Check if anything's in your Y, like at the way bottom, like go to your Y equals and go all the way down.
No, she got it.
All right, so second, we want to put in, let's put in square root of x. Good?
Oh, thank you.
We're doing it on our calculator.
Oh, I haven't touched it. Is it the stuff that you downloaded or just?
No.
Oh, I can do it too.
Yeah, everybody can do this.
So we bought it and then.
Okay, so let's graph it.
Gracias.
I'm gonna just make sure. So, Maytal, you were just asking, whenever your window isn't from -10 to 10, if you just press zoom
6.
and then number 6, that automatically puts it from -10 to 10. So zoom 6 will graph it -10 to 10, -10 to 10. Okay, so here's my square root of x. All right, we are going to press the second and then the trace button. And yours might be a little different over there, I'm not sure.
We go to
Second. Trace.
Yeah, ours is
Oh no, integral f.
Ours is
Yeah.
F3.
Okay. All right, number 7. Do you see how it has the integral of f of x? Okay, so you can either press 7 or just go down until it's highlighted. So it's going to ask you for your lower limit. So type the lower bound, which is a. So we said it was, we were using the example from 0 to 4, so you're going to type in 0 and then press enter. So here I am, step 5, type the upper bound b and press enter, so that's 4. And then press enter.
What if
So
it
what
doesn't
will
reach
happen
0?
is it will shade it in for you, and it will give you a result at the bottom. 5.333337.
Mine, someone's showing.
On test, it won't work displaying them. Or will we be able to look up
This makes no sense.
Oh, I think the equals doesn't
Wait,
highlight it.
what do you think?
Trace.
How do you type
Second,
in?
so we went second, trace.
Right.
Number 7 is the integral. It's gonna ask you for a lower limit, so I'm gonna type in 0, press enter. Upper limit is 4, press enter. It's gonna shade it in for you, of course I just already did
Wow,
this.
it's blue.
And you get your answer. So that means, okay, tell me what this means in terms of the integral. That's the area under the curve from 0 to 4. What
It's saying
happens?
it's invalid.
What happens if I change the bound from 0 to 6? It's gonna get a bigger area, right? Okay, so that's one way. That's by putting it into Y1. If you're more a visual learner and you like to see what you're finding the area of, then I would recommend this method. So let's look at method 2.
Wait, do we write the answer?
Sure, if you want. You're gonna get the same answer for, I gave you 3 different methods.
On test.
Hey, that guy showed does it. Ask me as well.
Yours should work, I'm so sorry.
Look at it.
Okay, the second method is just typing it in. So go to your home screen, which just means this blank screen here. That's your home screen. You're gonna press math and then number 9. So math. You could either scroll down to number 9 or just press 9.
Whoa, I got FNINT.
Oh, okay, so some of you
I don't have
have,
the silver edition.
all right, I'll explain how
I
to
have
do
the
this.
same thing as you. I got. And I got the same. I did it over.
You-
Let me see.
So you just type it in, so we type in 0, and then use your arrows to get up or down. So we go up, and I'll type in 4, and then we'll go over, and I want to type in square root of x, and then I'll go over, and don't forget the last part is to put in here,
Could it be just a
dx.
head?
Well, how would you do DU and D, like,
And you'll get the same answer that we got when we graphed it.
Yours is
Okay, so on here, if it just showed up like this and not with the little kind of missing pieces,
I don't know.
so what you're gonna do for function integrate, you're gonna type in the square root of x, so do square root, and then x, and then, does it automatically show up with a parenthesis?
Yeah.
Okay, close parenthesis, put a comma.
Wait, don't close the whole front.
No, don't close the whole parenthesis, just the one with the square root.
Comma,
Comma, and then put your lower bound, which is 0,
0, comma, 4.
and then put 4, and then one more comma. You need to put an x at the end, and then close parentheses for the whole thing.
And enter. Oh, I got it.
Oh wait, did I? It's been a while since I did this.
Yeah,
You know what? Hold on. I think I switched these two. Sorry, guys. Switch. Put the x right after. Okay. Now try this. I think this will work. Sorry, it's just been a while since I used the older version.
Yeah, we got
Yeah,
it.
you get to check your answer using your calculator. There will be some I'm going to say using, so I didn't show you how to do the integral of square root of x. Square root of x doesn't look like a circle, it doesn't look like a triangle, but I will show you later a formula to find it. So for right now, if you came across square root of x, the only way we have is using our calculator. Okay, the last method, method 3, is using the calculator program.
That, we already know how to do that,
We
right?
know how to do that. So let's just run through it real quickly. It doesn't hurt. So we're going to go to our program, and we want the Riemann. So that's number 1 on mine. I don't know what it is on yours. Press enter. So we're going to type in.
Partitions, we don't do 4, we do.
Okay, so I'm going to get to that. For f of x equals square root of x, press enter. So our lower bound is 0. Enter. Upper bound is 4.
Oh, I know how to do it.
Partitions, for this, since we're looking for exact, it's not really important. Just put any number in. You know, you could put 10, you can put 8, you could put 5. I mean, it doesn't matter. Just put something. Don't put 0. Don't put like 1,000. Put a realistic number. So it's going to give us that. But because I don't really care about the left sum, the right sum, the midpoint, all I want is the definite integral, which is what the area represents. Just type in 6. And it's going to shade it in just like it did for us earlier, but through the calculator program.
Our calculator.
oh, so calculator
Okay, so the calculator program would be, so for example, maybe on the test, I will give you one problem, and I'll say, okay, do the left-hand endpoint, and then do the right-hand, and then tell me what the definite integral. So if you're already using the calculator program, it will be easy just to do this. Another example of where you want to use the formula, you know how sometimes when you graph it, it doesn't get you the look of the, maybe it's not zoomed in to where you want it. Like it's not a really good picture of the graph. This calculator program will always graph it for you in the ideal window. Oh, sorry. Okay.
How do you get over there?
Press enter. And then number 7 is right. So let's continue. Example 1. Oh, that's right. Right here? Okay, so again, when we evaluated this, so you have a way on your calculators now, even though we solved this using area, could you plug this into your calculator and check? Yeah. And it should come out, obviously your calculator is not gonna give you an answer with pi in it, it's gonna come out to like 6.28, but you could still verify. So that's the nice thing about this, using your calculator to check.
But how, oh, it's from -2, see?
Yeah, so I could go to y equals, and I could do square root of 4 minus x
Yeah.
squared. Oops, I have an x in the wrong spot. Oh, it still has the same balance, that's okay. So then if I go second calculate, and I want number 7. Oh, you know what? Let me zoom 6 first. There we go. There's my semicircle. So if we go to calculate, and we do number 7,
Wait, is this on the program?
I'm just doing it in the graph. So I went -2. Oh, I see what I did.
Shoot, I left my job.
-2. And then upper limit is 2. So it's gonna shade it in and see how you got 6.28.
It looks like a sentence.
Wait, but I don't understand what the point of the DX is like within the
We should
function.
do that, but we know.
The dx is, at this point, dx is,
Nothing?
just think of dx as notation and it doesn't, it will have some implications later, but for this lesson, it's all about area. That's all you need to remember. And this next example I'll show you. So we actually did this on the very first day where we had a train that was going 75 miles per hour. It was a constant rate. So if you have a constant rate, you always have a rectangle. Make sense? Everybody
Yes.
good?
You have constant.
So here's that revisit problem. A train moves along a track at a steady rate of 75 miles per hour. So what I want to do is I want to use integral notation to just write this out. Okay, so I want the integral. So tell me, who can tell me, what would be my bounds? What's my lower bound? 7 in the morning. And what's my upper bound? My 9. And it's a steady rate of 75 miles per hour. So 75.
Why would we put?
And then I'm going to put D. You could, okay, so here's where when you have a constant rate, the variable is not really that important. I put dt, it could be dx, it could be dy, it could be dw. I just use t because I'm referring to time and the distance traveled.
Why would we have like function?
This is my function. This is my function. My function of time
So it's
is
150 something.
okay, what I'm trying to show you guys is it's just, this is a rectangle. So whenever you have a constant, it's just subtract the bounds, 9 minus 7, times 75, times that constant rate.
So the integral would be 150?
Yeah. That's, you can use this anytime it's a constant rate. Above. Right here.
And you want us to round 3 as well, right?
Here. If it's a constant, you can just do b minus a times c. Whatever c is a constant.
Oh yeah, that makes sense, because if you like write it out normally.
Yeah, the constant, think of the constant as the height of my rectangle, and the base of my rectangle is from A to B, so the length of my rectangle would be b minus a. Look at the shapes here. Here, b minus a, right? This is b minus a, and my height is c. What happens if it goes below the x-axis? It just ends up being an integral with a negative result. A brace. Yeah, no, this is great.
Do you need units for that?
I know.
Do you need units?
Compared to Friday, this is like.
And
Go ahead.
we
Do you
can
need
use our
units? No
calculator.
problem.
Oh, yeah, I probably should put, since this was a word problem, so this will be 150 miles. These we don't need units.
Are we allowed to use our calculator?
Yes.
For these?
Yeah, but I don't need, you don't need to. Because,
For like A and B type
okay, so I would say no, but I'll, just here. It's the constant, which is -6, and then 7 minus 3. Subtract the bounds, multiply it to the constant.
Negative.
So -24.
I like those better than the word though.
Yeah.
This one is going to be pi over 2, and then we have -1 minus -4, so that would end up being +4. Good. So we get 3 pi over 2. I mean, that would be fine, just leave it that way. Don't overcomplicate
Is
it.
there gonna be like, is it gonna get really complicated, like how like you roll or whatever it is, or something?
Eventually, but not till next chapter.
And that's gonna be the
step by
hardest
step.
chapter.
My goal is to try to get as far as possible because I know that like once multiple living and all that stuff happens, it's gonna be really difficult.
We don't have to, hopefully the only benefit.
Right, you have to go to,
In this class.
you either have your senior internships or you're on March of the Way. Yeah, review, so we have final review and then the final. It'll go fast.
Crazy. So like basically our spring break is like a month. Right? Pretty much
Well,
we're
you
done.
don't- we
At
don't
the
still
shop
have
zone,
some-
when we hit the shop zone, we're like.
We'll still have material to cover, so.
Not
All right. Come on. All right, so let's use the graph. Let's use the graph of the integrand and areas to evaluate each integral.
What's integrand?
The integrand is this. Okay, so what we want to do is go ahead and graph y equals -2x plus 4. Think of, it's a curve, so think you're graphing y equals something. Well, what does y equals -2x plus 4 look like?
What color?
By hand, Lauren.
From
It's a line
it
with
has
a,
a negative slope.
with a y-intercept at 4,
I'm gonna
Do green, because she's doing
Green, okay, I'm gonna do green.
and it has a slope of -2, so down 2 over 1, down 2 over 1. And I only want to look at the graph from 0 to 1. So actually, I'm going to cut it off here. And I just want this area here. I don't really care about what happens from 1 to 2 because my upper bound was 1, so that's where I stop. Now, what kind of shape do we have?
Trapezoid.
We have a trapezoid. Now, if you don't like trapezoids, you can always use a triangle and a rectangle, right?
Yeah.
I like trapezoids, so I have no problem with
Weirdo.
them.
What do you have to do? It's
I'm gonna
not-
do,
Nobody likes trapezoid.
so,
I love chocolate.
okay. This is technically my height here. My height is 1. And here will be my
Life.
base 1, which is 4. And my base 2 right here. My base 2, which looks like it's 2. So my formula for a trapezoid is 1/2 times the height. So notice,
Are
it's
we
a sideways
given this?
trapezoid. It's a trapezoid kind of like when we did trapezoidal rule.
Are we gonna be given the like
Sideways.
formula?
No, you would be expected, if you don't want to use trapezoid, just do triangle and a rectangle. And then base 1 is 4. Base 2 is 2.
Three.
So the hardest part is basically graphing and getting the right area that we're looking for. Because from there, hopefully you remember how to find the area of a rectangle and a triangle.
The little like tip triangle that like fits right in if you like on the vertex.
Exactly,
You
so
literally
you-
just turn it. and
You
it's-
could see that this, so this rectangle here has an area of 2. And this one is exactly half the size, so that has to have an area of 1.
No, I was
Is that
saying
your-
the
oh.
very tip from 3 to 4, that little triangle. If you turn it along the vertex of half 3, and you turn it, and it goes right into the rest of the square.
Oh.
So 3's consecutive.
Okay, whatever helps you.
Someone drew on the desk.
That's awesome.
Was it something nice?
No, it was just some detail.
Okay. All right, so you guys know how to draw this one?
Oh hell.
What?
Here.
It's just a triangle.
Hold
It's
on.
upside down.
It is. Let me rewrite it. How about if I put a negative absolute value of x, and then I put a plus 1? Does that make more sense?
Kind of.
It's an
Absolute
upside
value
down.
is
Okay, so
this.
absolute value looks like a V. It's turned upside down and it's moved up 1. So it looks like this.
Oh, but it's only to.
It keeps, okay, so it would keep going, but because we specifically want to look at from -1 to 1.
It's just one because it's 2 halves of the squares.
Isn't that nice? Or you can just look at it as a triangle, whatever. Again, I don't care how you break up the graphs, whatever makes more sense to you. If I want to do the triangle, be 1/2 the base is 2, height is 1, so we get 1. And this is what your homework looks like. So it's mainly graphing and then just figuring out the part that you, and I actually have some graphs over there, guys. Okay, oh, this is just using your calculator. Let me just look at one more example, and then I think we're done. Okay, this graph, can you guys, if you don't know what this looks like, can you put this in your calculator?
Yeah.
Yeah, we skipped that. It was just plugging in for a calculator. Put that in your calculator. What's that look like?
Like 8.
Okay.
So, how do you do absolute value? Math?
So you put in math and then go over to number and then absolute value. Yeah, it's 2 lines.
-1 minus 4.
I did it one way, did it plugging it in the calculator. and
Oh,
then
it's like this.
It's 2 lines. Well, think about it. For every value I plug in, like so if I plug in 2, 2 over 2 I would get, which is 1. What if I plug in -2? I get 2 over -2, which would be -1. So for every value, it's going to look like this. It's going to have an open circle, because it can't have 0. And then it's going to jump up here, and it's going to keep going. Ah, yes. So we specifically want to cut off our bounds from -1. So here is -1. So I'm looking specifically at this region. Notice it ended up being below the x-axis, and then we're going to continue it until we get to 2.
So just looking at that, isn't it just 1?
Yeah. So there were 2 parts to the problem. Find the points of discontinuity. Point of discontinuity is at
Oh, X equals
at x equals 0. So now use area to evaluate.
But we
So
just know it's 3, right?
can you see that it's -1 on the bottom and then
so
2? So you get a total integral of 1. Because remember, anytime it goes below the x-axis, we count that area as a negative. The area, this square has an area of -1. This rectangle, or some of you may have noticed that this square and this square are going to cancel each other out, and then you just have 1 square left over. Whatever's easier. The last 2 problems I skipped, but that's just because it was just a matter of plugging into your calculator. So, yeah, sure. How do you want to do them? You want to do them according to the graph
I
or
like doing the math 9.
the math? Okay, do math 9.
Because I want to know if the way I'm doing it.
So -1 to 2. Make sure your calculator is in radians for this first one.
Oh.
So just go to your mode,
Oh.
verify that it's in. And we get
2.0.
Where's the way for me to do that?
2.043.
Whoa. Did not get that.
2.043 is your calculator in gradients.
I just put it straight. I did f n int x sign parentheses x close parentheses comma x comma -1 comma -2. No, -2. That's one.
Okay. Go ahead and type in the next one. So we'll do math 9. So we have rem 0.
It was a bad day.
Got it.
And then 4 divided by 1 plus x squared. Oh, let me close
Do
parentheses.
you need to put a dx? No. In your document?
No. And 3.142? No, but you didn't get that.
Yeah, I got
3.1. Whoa, I thought 3.1. No, 3.142. Yeah.
Yeah.
I like agree.
Okay, I'll check.